G'day, Michael here. This video, I'm going to try and keep it short and sweet. There's a lot of information to cover, but I'll try and do it quickly. This video is about tuning one of these things, these Delta printers, so as to get good, accurate prints. There are a couple of errors you'll see with these things, and I found the best test shape is a test hexagon. Now, to have an understanding of how it was going in the machine, I put a hole in what was being printed in the front of the machine. So I'd be sitting that like so in the machine. I'll just zoom in on it, less on me. Is that a reasonably good picture? Yep. Okay, so the hole is towards the front here, and that's just as a reference to me so that I can see what its orientation was in the printer. Now, if you measure, so put some, I don't know, some masking tape or something you can write on or draw onto the table here, and measure distance in either way, a constant distance. Like this one here is exactly 150 millimeters. The firmware file says 151, but that's not what it's worked out to be. If you have some errors where you've got one of these offsets different to the other, you may have to shim up your bearings here. On the original bearing mounts that came with this machine, I had like adjustment nuts. On this, if I had to adjust these, I'd be putting like a little washer in as a shim. These are all identical and I'm very happy with the result, so my three are accurate now. My previous iterations I had to adjust these. Okay, so if your test diamond is pretty well right, except you've got one axis a bit odd, when you do the test diamond, of course, you'll be able to see which axis that is. So it's not a matter of X, Y and Z. You'll be able to see directly if this dimension across here, which in this design is 100 millimeters, is, say, correct in line with this axis, then you're happy. If it's incorrect on one of the axes, like this axis, let's say it was, I don't know, 98 millimeters, you know you'd have to do some big change here, right? So I always get this back to front because it exacerbates, my thinking always goes the wrong way around for some reason. I just can't seem to get in my head why. I figure it out and then I forget what it's about. Basically, its assumption is one thing and what it does is kind of the opposite. If you've got an error, if it's too small it'll make it too big and that kind of thing. So yeah, for some reason that doesn't go in my head. But in any case, try something. If it makes it worse, go the other way. So that's basically the method I'm using. Funny enough, it doesn't take long to even trial and error to tweak those last little bits out. So if you did this test diamond and it was only one axis out, you'd shim that one axis or whatever. If all three of them are out, then you'll know that there's an adjustment to be made in the firmware. Now, these three bearings that we have here are quite nicely identical. The posts are quite nicely equidistant from that center point. So that bit, I didn't have to tune mechanically on this, but your machine may need that if you're getting one dimension wrong. If you're getting an out of round circle, do a test diamond like that, and then you'll have something to measure. But make it 100 millimeters across the flat, or something you can measure easily with whatever your measuring gear is. And believe it or not, a decent steel rule is good enough for the job if you get a large enough size. So you might want to bump that out to 150 millimeters or whatever. So the bigger you make the object that you're printing, the more it'll tell you about the errors of the COSL. Alright, so I've got these test prints numbered. Now this one you can see is number 1. Okay, let's just get some focus. There we go, number 1. This guy, I'm holding it relative with the dot down, so that's the front of the machine. Number 2, which was written that way of course, but that's its orientation in the machine. And number 3, which has turned out to be bang on 100 millimeters, and it is flat across the surface. Okay, now number 1 measured about 97 and let's say 97.6 across flat to flat, so it was wrong, and that's a big amount wrong. So I tweaked the numbers. I'll show you what the numbers are in a minute. and I've got this, which is a bit over 95 millimeters. So I've gone about 2 and a bit millimeters the wrong way. So what I did is I went the other way, and I ended up with this, which ended up being quite perfect. Okay, so the first one was wrong. I made an adjustment of about 2 millimeters. It made it wronger, but by the right amount. So I reversed that number and got a right result. So it was that easy. Now, you do have to upload the firmware to the controller on your printer. Mine's using Arduino. Most of them I think use Arduino, but there are a couple of other common controllers out there. In any case, I'm going to show you the Arduino tweaks. I'm sure that the other systems will have something similar, because at the end of the day they're doing the same job. So that's important to know these numbers. But the test diamond is the big trick. Not diamond, hexagon. I keep saying diamond. So this test hexagon is the answer to your measuring problems with the COSL. I haven't found any other shape. Well, I just really can't conceive of another shape better than that, because you can see a measurement that relates to each individual axis and the nice flat surfaces to measure to, and with that hole there you can tell which way it was the front, so you never lose your place. Okay, so let's have a look at the Arduino software. Okay, because of my various printers, I've got the Black Widow, I've got the Prusa, and I've got the COSL or the Delta machine. I've actually had to have 3 different versions of Arduino. What is kind of nice, I'm using Linux. I can actually run the Arduino straight from the stored file, basically extract it and it'll run. So run, yep, that's good. Okay, so there's the Arduino interface running. I'll open the sketch. Where are we? Server. Wow. Okay, so what I did when I first got the file extracted, I copied it and labelled it backup. I don't know whether you can see that. You should be able to see that, hopefully. Yes, no? And the one I'm actively working on is this. Okay, so let's put that where you can see it best. Now really, it's quite, on one hand it's a big file, well actually a group of files and libraries and bits and bobs. But all we're interested in is configuration.h, which is about the 4th tab along. Now, this was supplied with my printer, so I didn't really have to do much research as to where to find it. With the Black Widow I had to go and find it and download it to be able to tweak the Black Widow. So, but this is for this Delta, and I have to use Arduino 1.0.5 with this guy. There's some, I don't know, some compatibility thing with newer software that wasn't quite working out. Anyhow, the path of least resistance just used an old Arduino interface. Alright, so I've scrolled down to COSL printer settings, as you can see just here. Right. Now, the diagonal rod, which I didn't measure before, but the diagonal rod that connects the various bearing bits and bobs together is 218 millimeters. That is in fact a correct measurement, and that's simply centre to centre, so that's an easy measurement to take, and it's easy measurement to get accurate. Okay, the Delta smooth rod offset. So that's my posts, let's say. They've got it here as 151. I measure on my machine 150. It's not that critical if you can't measure these accurately, because at the end of the day these numbers are used to create a variable called delta radius. So you have delta smooth rod offset, which is that. Where are we? Right. Take away delta effector offset, which is that. Take away delta carriage offset, which is that. So it's 151 take 25 take 18 gives that number. Alright, so delta radius. And as far as I'm aware, that's the only number that gets used through the program. As you can see, delta radius everywhere. Right? I haven't seen any impact of these other numbers being carried through anywhere else in the program. But having said that, I'd still like to keep them fairly close to the real numbers, but I haven't found anything stopping me from printing being like a millimetre out here. What is important is the net result of this delta radius. So if you can measure something more accurately, and you can tweak the actual numbers. Like this I couldn't measure accurately, this I could not measure accurately, this I could have changed to 150, but at the end of the day this carriage offset and that are kind of a combined, they relate to each other, and this is the effector offset. So at the end of the day I can't see any other implication than its total number output of the delta radius. I haven't found any reference to that elsewhere. I haven't really done an exhaustive search, but that seems to be fine working with that. So all I did was, originally it was 22 when I first bought the machine with the original carriages. I've tweaked around, ended up with 18.6. In any case, when you are to change these numbers, to get it onto the printer, you actually have to go, you see there's an arrow here, and it'll compile it and then upload it to the printer. You will have to find out what your configuration is for your particular printer. On mine, you go to Tools. The board is an Arduino Mega 2560. The serial port, it's not plugged in, so it's not letting me adjust that. The programming interface is USB Tiny ISP. I don't really know what that is for exactly. You can probably look it up and find out. But that's what the configuration is for this machine, to talk happily to the Arduino. Alright, so when you've changed these numbers, you press upload. You'll see any compiling errors, anything that you may have changed there, or anything that sees wrong. If you're missing libraries, etc., which I had on the TiVo, you may have to add libraries in the interface. Now the various versions of Arduino need slightly different details. This remains fairly constant across them. And if you have some other controller other than Arduino, you may have to find the specifics there. But at the end of the day, what this video is relating the real world to these numbers and then sending it to the printer to correct. So I'll go back over what I actually did here. This is the first test hexagon. I made a change. This is the second. It was wrong. The number I changed was this carriage offset. It's arbitrary which one of these three numbers you change. If you can measure accurately, you may as well use accurate numbers. If you can't, don't worry too much. It's just this number, take away these two, gives delta radius. So that's the number that has to work out correctly all in the end. And the best test was to do that test, make the adjustment, till I got this result. This is exactly 100 millimeters across the flat to flat. If you have one axis that's standing out, you might have to do a mechanical adjustment. Again, I'd put a washer or something in there and see if it gets worse or better. So you won't have too many tests. I reckon within 3 tests you'd probably nail it, but if you need a 4th test, I'd be surprised. If you know what you're looking for and you can puzzle it out by looking at it, you might even do better than that. But you know, you won't have to do this very often to get it right. Anyhow, I suppose that's it from me. Feel free to like, share, subscribe, ask a question, leave a comment, make a suggestion for another video. That's it from me. Bye now.